Alright, so we're moving on to topic 1.2, which is just about rates of change. In this class, we're going to kind of talk about two different types of rates of change. One of them, or both of them, when you think of rate of change, just always think about slope. That'll make it easy to kind of keep straight in your head. We're talking about slope. Sometimes you're talking about the slope at a point, which is what the first few examples are going to be. And that's like how, if you were to change just a little bit at that point, how it would be changing in a super, super, super small interval. Now, we cannot find the rate of change at a point without using calculus, which you guys are not going to learn any calculus this year. So we just kind of determine, we can order the rates of change at a point. We can determine if it's 0 or positive or negative. That's all we're really going to do with it this year. Now, if you take calculus, we'll do tons and tons with it. All right, and so one thing that is helpful to think about, like a roller coaster. And if you're on a roller coaster, if you are going up the slope, up the incline, then it's a positive rate of change. Like at the very, very maximum and minimum points of the roller coaster, you're not really changing. That's going to be a 0 rate of change. And then whenever you're going down, that's going to be a negative rate of change. So think about it as a roller coaster kind of helps. Apparently, there is this crazy roller coaster called the Formula Rossa in Abu Dhabi that it reaches 149.1 miles per hour. I will not be getting on that roller coaster. That's faster than an Indy car, so it's kind of crazy. All right, so let's look at example 1. So we have this function, and we have 3 labeled points, and we're going to order those points as the rate of change we're going to order the rates of change of those points from least to greatest. And so if you're trying to think about rate of change, I think it's a good idea, just draw a little slope at that point. A little slope that goes along the line at that point. So that little slope, would you say it's positive or negative? That A is positive. All right. What about B? Yes. All right. What about C? Yes. Nice job. So the relative max and the relative min points are going to have a rate of change of 0. All right. So what about the least? What's the least? What's the least great? The least rate of change. C is 0. Would a negative be smaller than 0?
No.
Yeah, so B is going to be the least, and then 0, and then the positive. So it is confusing. 0 is the least steep, but a negative number is going to be the least rate of change. All right, let's look at the next one. So now we have 4 points. And the question is, on which of the following points, at which is the rate of change the least? All right, so we have a positive, a negative, and a negative. What do you guys think is the smallest rate of change? D, the one that is negative and the steepest. The steepest negative. It's going to be D. All right. Now, so we're going to do very little with rate of change at a point. We are going to do a ton with average rate of change, like so much that you'll be able to find the average rate of change in your sleep. Today we're not actually going to be finding a lot. Again, we're just going to be ordering it. We're also going to determine contextual situations where the rate of change would be positive or negative or 0. And so the next lesson, topic 1.3, we're actually going to spend 3 days on it talking about average rate of change. But today, let's just order the average rates of change. And so on graph H, we want to find on which interval is the average rate of change the greatest. So this is what I would do. The first one is the interval from 2 to 3. So I would go on the graph where x is 2 and put a point on the graph. And we're going to 3, so I'd go to where x is 3. And the average rate of change is going to be the slope of the line between those 2 points. What would you guys say that slope is? That's going to be 0. Alright, so let's look at the next one. The next one is from 3 to 5. So we already have 3. 5 is going to be about right here. So we just connect those points. Alright, so that's a negative. Is there any way that's going to be our greatest rate of change? No, because 0 is already bigger than that one. Alright, and then we have 5 to 7. It's looking pretty good because that's a positive. Alright, and then our last is 7 to 8. Alright, so what do you guys think? Which one is going to be the greatest? Let's see. Which one do you guys think is going to be the least? D. So D is the least because that is the steepest negative. The steepest negative is going to be the least. The steepest positive is going to be the greatest. Example 4 takes us to some contextual situations. And so the graph of the function y equals f of x, and the xy plane always has a positive or negative rate of change. Which of the following, always has a negative rate of change. Which of the following definitions for the variable xy would best model the function? Alright, so whenever the function always has a negative rate of change, as the input goes up, what should the output do? Go down. Okay. And so A says the age in years of a young child is the input, and then the output is the height in inches of the young child. So as the age goes up, should the height go down? No. So that's wrong. Alright, and then B says the input is the total number of points scored in the basketball game, and y is the time remaining in seconds of the game. So as the points go up, would the time go down? Yes. That is really weird for the output to be time, because usually that's the input, but that is the answer to this one. And then the other two should, well, the next one, the ball's thrown straight up in the air, the height in feet, sometimes that is increasing, sometimes that's a positive rate of change because it's going up, and then it changes to negative, so that would not be the answer. And then the radius of the circle, as it increases, the area also increases. All right, the next two we're going to use a calculator to do. So go ahead and open your calculators. You can always use your own calculator. I just put them out because my students are going to need them the rest of the day. All right, so go ahead and go to y equals and type this in. So I have it typed in already, but I will wait for you guys. Actually, yours might already be typed in from my last class. No? Okay. So we are going to change the viewing window quite a bit this year, but right now this one is going from -10 to 10, and so -10 to 10 is always zoom standard or zoom 6. Okay, and so this question is about the rate of change and where it's positive and where it's negative. So we have on this upside down parabola a rate of change that's positive in this section of the graph. And then as we go across the maximum, then it's a negative rate of change. So do you guys remember how you'd find this point right here? We want to find the maximum, yeah. So to find the maximum, we're going to calculate it. So to calculate the maximum, you hit second and then trace. And then from here, I bet you could guess that you're going to choose maximum. Now, if it was a parabola, like the parent function parabola over there, where you have a minimum for your vertex, you would choose minimum. But in this case, we're going to choose maximum. All right, you get the little flashing cursor. And so we want to move close to the maximum, but stay on the left side and hit enter. And go over the top and start going down the roller coaster on the other side. Now, on the yellow calculators, you don't get those lines, so you just get the two arrows. So you're telling your calculator to find the maximum point between those two arrows. All right, and then just hit enter. There it is. So this question is written in a way to kind of trick you if you're not paying attention. So we know we're changing over from a negative rate of change to a positive at the maximum. That 8 on part A, that 8.348 is part of your maximum, but is it the right part? No, we want the x. So it even says x right there. So this one doesn't make any sense. I'm not really sure about the next one. I haven't looked that closely. I think maybe those are the zeros, and that's where the function is positive, but we want to know when the rate of change is positive, so definitely not B. All right, and then C says that K has a negative rate of change from negative 10 to 2.47. What do y'all think? That's wrong. So hopefully D is right. A negative rate of change from that 2.470 all the way to 10. Any questions on that? So it's just to see if you guys can find the maximum and minimum. All right, the next one. This example gives the life expectancy of U.S. females born in a given year over successive 50-year intervals. Over which of the following intervals is the average rate of change in life expectancy the greatest? So these are all increasing by 50. So the greatest rate of change would be whenever the life expectancy has the greatest change. If we actually wanted to find the rates of change, it's going to be the change in life expectancy on the top of the fraction, and then the change in birth year on the bottom, which we know is all 50s. All right, and then to find the top, what we do, and I'm going to let you guys just trust me, we're going to take the 46.10 and subtract 41.24 from it. And if you do that, you get 4.86. And then for the next one, we're going to take 53.63 and subtract 46.10. That's going to be 7.53. So that's a nice jump. All right, and then the next one, we'll subtract 70.65 minus 53.63, and that's 17.02. So I think something important happened during that time span. Maybe the invention of penicillin. I think that might be what it is. I'm not 100% sure. So what do you think? Which intervals is the greatest? Yeah. All right. What questions do you guys have? Okay.